Hello everyone and welcome to another episode of Java Graphics. Today we're going to be talking about how we can detect collisions between objects, graphical objects like rectangles and circles with the edge of the screen. Now, full disclosure, we're not going to be overcomplicating things. We're not going to be talking about frame rate. We're not going to be talking about the width or the height of certain graphical objects and what happens if maybe the frame rate is such where they can move through them. We're not overcomplicating it. This is a basic video talking about how we can detect collisions with the screen edge. So that being said, if you've missed any of the prior videos where we drew circles and rectangles and made them move, I'm going to put a link in the description below so you can catch up on anything you may have missed. So let's get started. If you want to learn Java programming, or just programming in general, subscribe to this channel. We put out a lot of videos that range from beginner topics to more advanced programming concepts. Also, please like this video, share it with a friend, and write a comment as well. It goes a long way to help promote a channel like this. Now, let's get back to the video. So first, let's look at some slides. Here's our frame in yellow, and we have this rectangle in blue, and we're going to be moving the rectangle. Now remember that in our frame, we have certain values. We have a left edge, which is 0 in our case. We have a right edge, which is 1,000 in our case. And we have a top and a bottom edge. Those are 0 and 500 respectively. Now the rectangle also has a coordinate. That's the upper left point of the rectangle. That's an XY position. And if the rectangle is moving to the left, all we need to do is check to make sure that the X value of the rectangle never gets less than the left edge of our frame, whatever those values are. In this case, we just want to make sure that X never gets to be less than 0. Of course, if we're moving to the right, we can't just check to see if X is greater than the right edge because the rectangle has a width. So the right edge of the rectangle is what we need to check. That right edge is X plus W, the X coordinate of the rectangle plus the width of the rectangle. Similarly, if we move up, we need to make sure that the Y edge of our rectangle never gets below the top edge of the frame. And if we're moving down, we need to make sure that the bottom of the rectangle, which is not Y, it's Y plus our height, that can never be greater than the bottom edge of our frame. So the first thing we're going to have to do in our rectangle class is somehow know where the left edge and right edge of our frame is and where the top edge and the bottom edge of our frame is. So we're going to need some instance variables. And in our constructor, we'll probably need to pass in those values. Now, of course, if you know that your frame is going to be 1,000 wide and 500 tall, you could get away with not passing in these values, and you could just say left edge is equal to 0, right edge is equal to 1,000, top edge is equal to 0, and bottom edge is equal to 500. But just in case you want to change the size of your frame, it's better to use variables. So let's pass in the top, bottom, left, and right of our frame into the rectangle. So let's go back to our main class. We're going to have a compile error here, yep, because we have to change. So let's pass in 0 as our left edge. We'll pass in width as our right edge. We'll pass in 0 as our upper edge. And we'll pass in height as our lower edge. If you remember, these two variables were set up here to 1,000 and 500. This way, if we decide later to change these values, we don't have to come down here and remember to change them here, or even go into rectangle and change them there. So now we have our rectangle. Let's take a look at how we can stop the rectangle from moving if we're at our left edge. So let's head down here to the move method. Now in the move method, we're saying that if we're moving to the right, we want to add 1 to X. Well, that's fine, but we want to stop if we hit the right edge of our screen. Same thing with left, up, and down. Let's start with left. So if we're moving to the left, let me expand this if statement so we can have multiple statements in here. If we're moving to the left, we only want to move to the left if X minus 1 does not put us off the screen. So we want to write an if statement if x minus 1 is greater than or equal to the left edge of our screen, then we want to update x and take 1 away from it. So again, this is checking to see if the new position of the x is still going to be on the screen, then we'll update x. And we're going to do the same thing for right, up, and down. But before we do, let's make sure that this works. So let's run our program, and I'm going to move the rectangle to the left, and as soon as I hit the edge, I'm still holding down the left arrow key, it stops. Now let's put the same code in for right. If x plus 1 plus our width is less than or equal to the right edge. Once again, we have to add the width because the right edge of our rectangle is what we want to check. We want to check to see if x plus 1 plus our width is still on the screen. And if it is, we'll move the rectangle to the right. We'll do the same thing for up and down. Okay, now I do want to make one change. I want to change the speed of our rectangle. I don't like that it's going by 1. You see, when I run this, it takes forever for me to move my rectangle. Okay, let's just double check the top. Okay, it stopped. Good. I'm still holding down the up arrow key, by the way. Now, it's moving a little slowly. So what I really want to do is I want to change this to maybe 3 or 4 or 5 or whatever. But the better way to do it is to actually have a variable. So let's go up to rectangle and let's set a variable here. Speed. And the speed is going to be how fast or slow the rectangle moves. So let's set the speed equal to 3. So now that we know the speed is 3, when we come down here and we're trying to move it, instead of adding 1, we're going to add speed and subtract it. So we're going to use this variable as the offset for how far we move the rectangle each time we come through this method. That way we can change it quickly instead of having to change 8 places. So let's run. And let's just double check the left. It still worked. Let's double check the top. It worked. Let's double check the bottom. It stopped. I'm still holding down the arrow keys. And right works. Now if I hold down right, if I hold down up and left, you notice when it hits the top, it doesn't move up anymore, but it still moves left, and that's fine. That's exactly what we want. We want to stop this thing from moving off the screen. Perfect. So let's start moving the ball around. The first thing we have to do is consider the direction that the ball can move. Now with the box, it was either moving left, right, up or down, or possibly a combination of those. But the speed was the same. If we moved to the right by pressing the right arrow, it would move a certain amount of pixels or units to the right every 1/60th of a second, every time the frame gets refreshed. With the ball, however, it could really be moving in any number of directions. We don't know which direction it's going to be moving. So instead of having a constant speed like we did with the rectangle, instead we're going to have two velocities. A velocity in the x direction and a velocity in the y direction. If the ball happens to be moving to the right, the velocity in the x direction will be positive. Could be 5, could be 3, could be 10. It depends on how fast it's moving to the right. If the ball is moving to the left, the velocity in the x direction will be negative. Similarly, the velocity in the y direction will be positive if the ball is moving down and negative if the ball is moving up. Now, if we have an x velocity of, say, 5 and a y velocity of 0, that means the ball is moving straight to the right. However, if the x and the y velocities are both 5, it will be moving down and to the right in a perfect 45-degree diagonal. But doing it this way with the different velocities allows the ball to move in any number of directions. For example, the velocity in the x direction could be 10, and the velocity in the y direction could be 1. In that case, it'll move diagonally down and to the right, but it'll be moving much faster to the right than it does down. Now, if the ball collides with the bottom edge of the screen, what would happen is we want the ball to actually bounce back up in this direction. We don't want it to go back the way it came. We want the velocity in the x direction to stay the same. It started out moving right. It's going to continue to move right. However, the y velocity used to be, say, for example, +3, moving down by 3 units every frame refresh. Now the velocity will be going up by 3 units. So it's just going to bounce back in the opposite direction, same velocity, just negative. Of course, if the ball hits the left edge, we're going to do the same thing. We want to bounce back in this direction. The velocity in the y stays the same. The old x velocity was, say, -5, for example, but the new x velocity will be +5. In other words, we keep moving up if we were moving up, but since we were moving to the left, now we want to bounce back and move to the right. Now, how do we actually detect the collision? Well, first we're going to calculate a new x value. The ball is about to move, and the new position that it's going to move to is going to be x plus the velocity of x, whatever that would be. In this case, the velocity of x is negative. The only thing we have to check is we just have to make sure that the new x value of the ball doesn't bring it off the edge of the screen. In other words, the new x value that we're trying to move the ball to can't be less than the left edge of the frame. If it is, we don't move the ball, we bounce it back in the other direction. Similarly, if we're bouncing off the right edge, we're going to again calculate a new value for our x position by x plus the velocity. And this time, we just have to make sure that the new x value plus the width is not off the right edge. Remember that the upper left point of the bounding box around our ball is the position of the ball. So we have to add the width, so we're checking the right edge of the ball to make sure it doesn't go off the right edge of the frame. Checking for a collision with the upper side is the same thing. We have a new y value where we're trying to move the ball to, and we just have to make sure that the new y value can't be less than the top edge. Hitting the bottom is the same thing. We have to make sure that the new y value plus the height, again, must not be greater than the bottom edge. So let's go to NetBeans and put in all this code and make it work. So here's our ball class. First thing we got to do, we need a velocity. And let's initialize the velocity. Let's say the ball is initially going to be moving down and to the right, but it's going to be moving a little faster to the right than it is down, as you can see. So there's our velocity, and now in our move method, what we need to do is instead of x plus plus, it's going to be x plus equals velocity, and y plus equals velocity y. Let's just test this and make sure it's working, but wait, before we do, if you remember, we commented out the ball moving so we can just handle the rectangle. Now we have to uncomment this so the ball will actually move. All right, let's test and make sure the ball is moving. And there it is. It went right off the screen. Okay, so far so good. Let's go back to our ball method. And now what we want to do is instead of just blindly adding the velocity to x, what we're going to do in our move method is we're going to declare two variables that'll represent the new position of the ball. And we'll say new x is going to be equal to the x plus the velocity of x. And the new y is going to be equal to y plus the velocity of y. Okay, so now normally what we would do is we would just set x equal to the new value of x and y equal to the new value of y, so the ball will move. Let's do that real quick. Okay, so we're setting new x, which is the new value. These two variables are the coordinates of the position of the ball that we're trying to move it to. We haven't moved it yet. This is where we actually move it, when we actually change the coordinates of the ball. Let's just run this, and it still moves down and to the right. Okay, that's perfect. Now what we want to do is we want to check this value of x and y, the new value of x and y, before we actually change the value of the ball's position. We want to make sure that it hasn't gone off the screen. So let's do this. Now you notice this is underlined in red. The reason why is because this ball doesn't know what the left edge or the right edge of the screen is. So we need to pass it in. So what we're going to do is we're going to change our constructor. We're not only going to pass in the position of the ball, but we're also going to pass in the left and right edge of the screen, just like we did with the rectangle. If you remember, in the rectangle, we changed it to pass in the left, right, top, and bottom edge. So all we're going to do is copy this code. Copy all this over to our ball. We now have this. Now in the rectangle again, we have these variables, left, right, top, and bottom edge. Let's copy that. Those will be instance variables here. And lastly, we initialize them. There we go. Now the ball knows about the left, right, top, and bottom edge of the screen. So in our move command, we're going to check to see if the new x that we're trying to move it to is less than the left edge, which means we're colliding with the left wall, or the new value of x plus the width of the ball, which is the diameter, is greater than the right edge of the screen. If either of those things is true, that means we're colliding with either the left or the right edge of the game. So what do we want to do? Well, we said that we want to keep the y velocity the same. The y is not going to change, but the x velocity has to become negative. If it was positive 3, it's going to become negative 3 and vice versa. So all we have to do here is we have to say velocity x times equals -1. So we're changing the velocity and making it the opposite, but then we also have to change the new x. So we're going to actually change the value of the x coordinate for what we're attempting to move the ball to. In other words, we were trying to move the ball to this x coordinate, but we've just seen that we're colliding with the wall, so we have to change the velocity first and then update the new value of our x coordinate for where the ball should be. So that takes care of colliding with either the left edge or the right edge. We want to do the exact same thing if we're colliding with the top or the bottom edge. So let's do another if statement, and this time we'll check if the new y is less than the top edge, or the new y plus the height, which is the diameter, is greater than the bottom edge. This means that we're colliding with either the top or the bottom. What do we want to do? We want to keep the x velocity the same. We don't want to touch that, but we want to change the y velocity, so now it is the negative of what it used to be. And then, of course, we have to update the position of where we're trying to move the ball to as such. Okay. So now we've calculated, let's just review, we've calculated a possible new position for the ball. We're checking to see, has the ball moved off either the left or the right edge? If it has, we're going to change the x velocity, the horizontal velocity, and recalculate the x position of the ball, where we're trying to move it to. We're going to do the same thing if we're colliding with either the top or the bottom. We'll change the velocity of y, and we'll recalculate the new possible position for the ball after we've changed the velocity, and then we update the position of the ball. Now the only thing left that we have to do is go into our main driver, and we have to fix our ball instantiation because now we're passing in the dimensions of the screen. Let's pass that in. And now we're good to go. Let's run it, and the ball should bounce off of all the walls. And there we go. Look at that go. Looks pretty good. Now, the nice thing about the way we did it with the velocity of the ball is we can simply change the velocity to anything we want. We could make this 2, and we could make this 10. So now it's going to be moving a lot faster vertically than it is horizontally. Let's see what that looks like, and there we go. That looks perfect. All right, we now have a bouncing ball. In the next couple of videos, we're going to handle the ball colliding with the paddle or the rectangle. We're going to handle 2 rectangles colliding. We'll handle 2 balls colliding. I hope you learned something from watching this video. Please remember to subscribe and share this video with others who are learning Java programming. Thanks for watching, and take care, everyone.